Unit 6, Lesson 7, Slopes of Special Lines. So today we're going to learn about the slopes of parallel lines, perpendicular lines, horizontal lines, and vertical lines. So just in case you aren't sure, parallel lines are lines that never touch. Perpendicular lines are lines that intersect at 90 degrees. Horizontal lines are lines that go straight from left to right, and vertical lines are lines that go straight up and down. Okay, so to teach you about each of these special lines, I'm going to have you do an investigation. So, let's investigate parallel lines. So graph the following lines on the grid below you. So remember from the last lesson to graph one of these lines. First, plot the y-intercept, and then move according to the slope. So this slope is 2 over 1. So rise is 2, run is 1. So I'm going to go up 2 and to the right 1. There's my second point. Now I connect the dots. And remember, I'm going to extend my line all the way through. Okay, let's graph the second one. So it has a y-intercept at 5, and then it has a slope of 2 over 1. So I'm going to go up 2 and to the right 1. And then I'm going to connect the dots. So when we look at these two lines on the graph, they are definitely parallel, right? Those two are never going to cross. So let's look and see if there's a pattern. So take a look at their equations, and what do you notice is similar between the two? Hopefully you notice that they have the same slopes. So that is the conclusion I want you to make. Parallel lines will always have the same slopes. So if I wrote down these two lines, okay, you could conclude that these two lines are parallel because they have the same slope of 4. Okay? It does not matter what the y-intercept is, as long as the slopes are the same, they will be parallel. Okay, let's investigate perpendicular lines. So let's graph the following two lines and then make some conclusions. So the first one has a y-intercept at +1, and then according to the slope I'm going to go a rise of 2 and a run, which is to the right, 3. So rise of 2, run of 3, plot my second point, now connect the dots. Okay, let's graph the second one now. So it has a y-intercept of +4, and then his slope is -3 over 2. So that negative always belongs to the top number if it's just out in front. So rise of -3, so that means down 3, and then a run of 2, which is to the right 2. So down 3, to the right 2. Okay, now I'm going to connect the dots. Okay, so look at that. These two lines were perpendicular to each other, right? They cross at 90 degrees. So let's look at their equations and see if there was anything that could give that away in the future. Okay? And here's what you should notice. Their slopes are negative reciprocals of each other. So what does that mean? So negative reciprocals means they are the flipped version of each other, right? This is 2 over 3 and this one's 3 over 2. And they are opposite signs, right? This one is +2 over 3. This one is -2 over 3. So perpendicular lines will always have slopes that are negative reciprocals of each other. So for example, if I gave you this line, y equals 3 over 4x plus 7, and I said, make me a line that's perpendicular to it, you would know, well, hey, perpendicular lines have negative reciprocals for slopes, so all I have to do is I need to take this slope, flip it, and make sure it's the opposite sign. So I'm going to flip it, 4 over 3, and then it originally is positive, so this guy's got to be negative. And then it doesn't matter what the y-intercept is. It could be anything. Okay, so they have negative reciprocals for slopes, right? They're opposite signs and they are flipped. The numbers in the fraction are flipped. That means they're perpendicular lines. So in conclusion, perpendicular lines always have slopes that are negative reciprocals. Okay, let's investigate horizontal lines. So here's a horizontal line, that blue line on the graph. Calculate the slope. So remember, the slope formula is slope equals y2 minus y1 divided by x2 minus x1. So we have 2 points on the graph, so let's label them as x1, y1, x2, y2, and then let's plug it in. So y2 is 5, y1 is 5, x2 is 5, x1 is negative 5. Then let's do the math. So 5 minus 5 is 0. This is actually addition, so 0 over 10. So 0 divided by 10 is just 0. Okay? So this is going to happen every time you have a horizontal line. The slopes of all horizontal lines are always 0. Okay? So I'm going to extend this a little bit. So if the slope of horizontal lines are always 0, that means that the equation of their lines will always have 0 in the slope spot. But 0 times anything I could put in there for x is always 0, right? Because 0 times anything is always 0. So this whole term is actually 0. Cancels out. So really, the equation of horizontal lines are just y equals b. It's just whatever their y-intercept is. Now that's reaching ahead a little bit, so if you understood that this time around, amazing. If you didn't understand that quite so much, don't worry, we're going to talk about that last part again in the next unit. So for right now, just know that horizontal lines have a slope of 0 always. Okay, the last one I want to investigate are vertical lines, so let's calculate the slope of this guy. So let's pick 2 points on the line. So it doesn't matter which 2 you pick. I'm going to pick that one and that one. So this one is at 3 and 3, and this one is at 3 and 1. Now I'm going to calculate the slope using the slope formula, because all you need are 2 points. Okay, so let's label the points x1, y1, x2, y2, and then let's plug them in. So y2 is 1. y1 is 3, x2 is 3, x1 is 3. And then let's simplify. So 1 minus 3 is negative 2. 3 minus 3 is 0. So that's our slope. So I want you all to take a calculator and try typing that in. Do negative 2 divided by 0 and see what you get. You're probably going to get a message that says error or undefined or no answer. Okay? And that's actually fine. That's what is supposed to happen. Vertical lines have slopes that are undefined, meaning we can't figure them out because they are just straight up and down. So whenever you get a slope of divide by 0, you say that the slope is undefined. Okay, so the slopes of vertical lines are always undefined. Definitely know that. Okay, now I'm going to extend a little bit. Okay, so I'm going to reach ahead. How does the fact that vertical lines have an undefined slope affect the equation of vertical lines? Well, because their slope is undefined, we can't give them an equation in the y equals mx plus b form. Okay, because that whole equation is based off of having a slope. And this guy doesn't have a slope. So, mathematicians make up a special way of writing the equation of vertical lines. So what they decided is the way you can write an equation of a vertical line is like this. It's always x equals a number. And the number that goes there is just the number on the x-axis where the line crosses. So it crosses at 3, so the equation of this entire line is just x equals 3. Okay, if I had a line all the way down here, it was a vertical line. You know, okay, it's a vertical line, it's going to have this special equation that's written this way, x equals a number, and then you just put in the number that it crosses the x-axis at. So this equation is negative 2. But again, this is reaching ahead. We're going to talk about that a little bit later. If you understood it, great. If not, don't worry. For now, just know that the slopes of vertical lines are undefined.